Hola, buenos días. Y esperamos un momento o comenzamos. ¿Cuántos somos? Ya somos todos, ¿verdad? Sí. Pues muy buenos días a todos y muchas gracias por su valiosa participación y interés en este webinar. Vamos a iniciar a presentar nuestros participantes por parte de nosotros. Ok. La introducción lo hago yo y luego le pasamos la palabra a la parte de Alemania, a la señora Mila, que va a hacer la presentación en inglés del rector, porque ellos son los fabricantes de esta tecnología. Bueno, comenzamos a la derecha, el ingeniero Ernesto Biestro, participar con nosotros, desarrollo de proyectos a nivel nacional en México. El ingeniero Jorge Muñoz es ingeniero químico en parte de Desmex para proyectos especiales y en la venta comercial y la atención. Yo soy John Francis, el director de Desmex y responsable de esta tecnología en México. Somos el representante de la fábrica HS desde hace 30 años en México. Bueno, comenzamos. ¿De qué se trata ese webinar? Queremos introducir la tecnología existente ya en varias partes del mundo, también en México, luego vamos a el manejo de residuos de policromado de tanto postproducción y postconsumo. Abajo ustedes vean, están en landfills y quemaduras de los desechos, se van en toda parte del mundo, así se tratan en muchas partes del mundo los desechos. Nosotros queremos llegar a un reciclado químico de esos desechos y así llegarle a bueno, tener los costos de fabricación bajando o también no llenando las lámparas. Y así llegamos a la economía circular que por fin a todos queremos llegar. Bueno, yo paso ahorita la palabra a la señora Mila Skokova. Mila, por favor, toma el control ahorita para su presentación.
Okay, buenos dias, everybody. I hope that I understood a little bit. Unfortunately, I don't speak Spanish, but I know that the purpose of this webinar today is the sustainability and in particular recycling technologies for polyurethane waste. Thank you very much, Mr. von Francis, Mr. Munoz, for the introduction and for arranging this very informative, I believe, I hope, webinar. And as far as I understood, I should start the presentation, if I was understanding it correct. And then I can also share my screen with the presentation, correct? Yeah, I see
please.
that.
Go ahead.
Okay, very good. Okay, can you see my screen now with the presentation? Can you see my screen?
Yes, we can.
Okay.
Yes.
So as we already pointed out in the introduction, the subject of today's presentation is the sustainable polyurethane foam recycling of all kinds of polyurethane waste and technologies which our company, H&S Anlagentechnik, has developed for this and put already into implementation. First of all, I would like to share with you the key points which I will be covering in my presentation. And they are addressing the critical questions surrounding the polyurethane foam recycling. In general, also for us, before we were investigating and developing solutions for polyurethane foam waste conversion, we were questioning ourselves what happens to the waste now and what should be the target of our technology and which kind of problems it should address. Then at the end, of course, we have already the basics for the chemical recycling from our past. And we decided to develop the technologies for different kind of polyurethane waste recycling. So you will have the information about which kind of raw materials are required for chemical recycling process, what are the steps of the process, how we were designing our existing equipment already. Then I will say a couple of words about the resulted products, recovered polyols, and the finished product as the polyurethane forms produced with recycled polyols. And of course, with great pleasure, I will share with you our experience worldwide, because we have already implemented several plants on an industrial scale in different countries for chemical recycling. A couple of words about H&S and Lagentechnik. I think Mr. von Francius mentioned already that we are based in Germany and we are a German engineering company with the rich legacy of more than 30 years experience in the polyurethane industry. Our portfolio emphasizes different kind of equipment for polyurethane processing technology, from state-of-the-art tank farm design for storage of liquid polyurethane raw materials to advanced blending stations engineered for precise component mixing online and in batch mode. However, of course, the most innovative core of our portfolio is the expertise and design, as well as production of reactor installations and technologies facilitating polyols recovery out of different kinds of polyurethane waste, supported by our own research and development laboratory. We have a track record of more than 350 successfully realized projects worldwide, and we are very much committed to driving innovation and sustainability, as well as excellence in the polyurethane industry. So coming to the first point of the presentation, what I already highlighted, what happens to the polyurethane foam now. I guess it's different, of course, from country to country, and it could be that in Mexico there are also some different regulations than in Europe at the moment, but still we believe in some cases it is pretty similar, because as we started to investigate this topic, we outlined this situation that in fact the majority of the recycling of the polyurethane waste is going to landfilling, and the rest, the very small amount, is being subjected to energy recovery and mechanical recycling. It's difficult to say for me now what are these percentages in Mexico, but I believe it is still quite high. So in fact, there is nothing which is being done for chemical recycling at the moment. But still, it is the only one solution to make the real closed loop cycle for polyurethane waste. And we were negatively surprised by this situation also in Europe, because there were no real sustainable solution for this, for non-kind of polyurethane waste, neither flexible, rigid, or integral form. And that was, of course, pushing us to develop the technology, which should be, first of all, a real and sustainable alternative to a mechanical recycling. And it absolutely must contribute to decreasing landfilling and incineration streams. Of course, this is very important, that it must be technically and economically viable. And the last but not least, it should be accepted by the polyurethane industry, so that we are, let's say, in the position to showcase these benefits of this kind of sustainable recycling technologies. So in general, as I'm covering recycling technologies for all kinds of polyurethane waste, because those are different, those are flexible forms coming from slab stock, producing mattresses, upholstery, rigid form like insulation forms, as well as integral forms like steering wheels and shoe soles. We have different technologies for all these kinds of polyurethane waste, which are based on different methods like acidolysis or glycolysis, depending on the form to be recycled. And also depending on the kind of polyurethane form, which must be recycled, we are using, of course, different raw materials. What is similar to each technology or for each technology is that one of the major parts is polyurethane foam itself. So it is in between 40 and 50%. It must be shredded, or in some cases even shredded and briquetted, compacted. It is valid for the rigid form. And it must be clean from any contaminations, because it is a crucial part to be mentioned. Contaminations, they are disturbing not only chemical process, but also mechanical. And at the end, it is resulting in the high amount of process waste, which we, of course, want to decrease, which we want to skip, because otherwise that is the question also of sustainability of this process. The second main component is always either basic polyols or glycols. It is also depending on the polyurethane form to be recycled, and then different additives and acids and catalysts. All those raw materials are available in the market, so we do not sell raw materials. We are providing then the information for our customers which raw materials and their specifications are required for recycling process, and they can be purchased whenever you need them. The process, it is also does not depend on which kind of polyurethane form to be recycled. The process takes place in the reactor vessel under specific conditions. Normally it is operating under quite high temperature of around 230 degrees and a nitrogen atmosphere. The schematic of the process is illustrated on the slide, where you can see the key stages of the process, like raw materials and polyurethane form introduction, heating, reaction phase, product cooling, and discharge. This batch process typically spends around 12 or 13 hours, of course, depending on the capacity of the reactor and also on the polyurethane form type. It's a batch process. As I mentioned already, it takes place in a reactor vessel. The equipment for different kinds of polyurethane foam waste also, from the first sight, maybe it looks similar. Of course, there are some specific differences. In case if we are handling flexible form, rigid or integral, it might look a bit different. Here's, for example, the 3D drawing of equipment for flexible form recycling for slab stock foam waste. This is always consisting, of course, out of core unit, which is the reactor itself, with all the peripheral appliances like distillation system, filtration system, heating and cooling, of course, storage and feeding system for liquid raw materials, which are supplied in bulk or in IBCs, in drums, and also feeding system for polyurethane waste, which is mostly designed as a silo with a special feeding system, feeding conveyor to the reactor. Of course, everything is automatic, operated by a control system with a very operator-friendly design. Here, for example, it's also a 3D drawing of the equipment for rigid form recycling, which also might look quite similar, as we also have here a reactor unit with all the auxiliaries, dosing of raw materials, here in IBCs, also cooling system and filtration, of course a lot of piping around, that's for sure, and dosing of PU foam briquettes in this case, with a different kind of silo if you compare it to a flexible foam technology. But that is a complex equipment which is of course, not only a reactor vessel. It's not enough. As you can see here, and especially here, there are a lot of other units involved to handle this process, to prepare the raw materials, to dose them in the right way, in the right speed, to filter the product, to handle it further, and yeah, to control the whole system. Now I'm coming to the resulted product, the parameters of the recovered polyols, and I have split it into several types, because if we are talking about flexible, rigid, or integral form, the parameters, of course, are different. The first example is covering the flexible form waste, and here you can see the parameters of this resulted polyol. In all cases, actually, the product itself is a recovered polyol, of course, of a brown or dark brown color, and the application of this product is, in most cases, the input form, so the similar form from which it was produced. And here these parameters, as you can see, they have the polyols for flexible form. They have almost the same hydroxyl number as the basic polyols for flexible form, and very low acid number, which allows their very easy use for flexible form formulations. And our customers who are using this technology, they are reporting replacement of virgin polyol up to 20%, even up to 60% for upholstery furniture without any quality issues. It always depends on the mechanical and physical properties of the form, and that is the limitation of the, let's say, percentage of recovered polyol which can substitute original one. Here is the example of rigid form recycling, a recycled polyol from rigid form. It is also, for example, typical range of hydroxyl number between 380 and 580, which is similar to the products with high OH number for rigid forms. Also low acid number, and a bit higher one for the forms with amount of flame retardants inside. It is also a kind of dark brown liquid, but the replacement ratio is the same. It is also up to 50% without any quality issues, which was already proven on an industrial scale many times. And it has absolutely no any negative impact on the product. For example, insulation panels. That is the most widely used application for this kind of recycling technology and polyols. The last example here of the recycled polyol properties are the integral forms. That is like shoe soles or steering wheels. Here we have some difference between polyester-based and polyether-based systems that you can see already based on the viscosity, because, yeah, as you know, polyether are more low in viscosity than polyester ones. So in fact, the recycled polyol, they are somehow copying the properties of the initial product, of the initial basic polyol, and therefore they are used for the same application then at the end. We have also made, together with our customers, different tests also with shoe soles and steering wheels, where it was replaced like 30 up to 40% of original polyol by means of recycled one, without compromising the quality of the final product. Here it is also an example of physical and mechanical properties of flexible form, for example, produced with 30% recovered polyol. All the parameters like resilience, hardness, compression set, they are all remaining in the same range. So there is almost no deviation. That was done many times, and our customers, they are producing it since a couple of years already. So there is no quality issues. The same situation is with the rigid form. Here is the sample with 30% of recycled polyol produced on an industrial scale on continuous lamination line for insulation boards. And here you see also that there is no difference between the original master sample and the sample produced with recovered polyol. So in fact, if I'm outlining the benefits of the recycling technology developed by us, is it first of all that, as you can see, it is accommodating all kinds of polyurethane foam. And moreover, we are reaching a very high yield because the outcome is 96% of product. The rest is filtrate, which is depending on the contamination grade of the foam, kind of distillate and some losses through the process, but this is really very, very low amount of process waste. We do not have any separation into 2, 3 phases, whatever. So it is very clean and environment friendly process. The products are depicting really very, very good parameters, stable hydroxyl number, molecular weight, and very good reactivity, which enables for sure a high percentage of substitution, up to 50%, as I mentioned, for different polyurethane foam applications, from slab stock up to shoe soles and other possible applications like prepolymers and closed cell forms, whatever. So it is no limits at the moment. We have tested recycled polyols in different kinds of application. What is important to highlight is that alongside with achieving this excellent quality parameters, the manufacturing cost of recovered polyols is also very competitive. And if we are comparing them with virgin polyols, normally this manufacturing cost is something around 30% lower than the market price of original polyols. One point which I was not mentioning here, this primary aromatic amines, this is also very important because not all the technologies which are available in the market, maybe worldwide, they can really prove that the resulted polyol is free from dangerous or toxic concentrations of primary aromatic amines. And in our case, it is below 1000 ppm, which is really very low, below allowable limit, legally allowable limit. And this enables absolutely safe handling and transportation of the recycled polyol from different kinds of foam. Doesn't matter from which kinds. So, and beside all these remarkable points, which I was already explaining about our recycling technology for different kinds of PU, the thing which is really remarkable from my point of view is that this recycling technology or recycling solution is not just a concept which is existing in our research and development facilities or in our thoughts or theoretical discussions. In fact, we have already put into operations several industrial scale projects, and they are already demonstrating all these points which I have mentioned, this innovative approach and the tangible benefits of the recycling technology. And the first reference which we had, that was the plant in Poland, Ikano Industry, former Dendro. That is the slab stock foam supplier for IKEA Group. Ikano is recycling since 2013. It's post-industrial waste, so in-house waste, and they're using recycled polyol in all their mattresses, which they are producing for IKEA. And this is already for more than 10 years without any issues, and all the products, meanwhile, coming from Ikano, they are containing recovered polyol of different amounts. The second reference is a plant named Renuva, which was made in collaboration with Dow and a chemical company in France, Orion Chemical Orgaform, as well with collaboration of such companies as Vita Group and Ecomobilier, that is the kind of extended producer responsibility scheme in France. The plant was installed for recycling of end-of-life mattresses, or actually flexible foam polyurethane coming from end-of-life mattresses and conversion into recycled polyol. The plant is in operation since 2021, already, as I mentioned, installed in France. The next one for the similar application, also for end-of-life mattresses, was installed in 2023 and is already successfully in operation, is the Retour Matras company, which were, let's say, the main business of Retour Matras was collecting of old mattresses and making a rebound foam from them. So now they were stepping one step ahead and recycling the foam by means of our chemical technology. Also, we had a semi-rigid polyurethane foam plant in 2015. It was in China for one producer who is manufacturing automotive parts, in particular automotive headlamps. So it was a smaller unit, and also for the first time for us for semi-rigid polyurethane foam application, and it is also working successfully. Rigid foam was coming in 2023. Now we made 2 projects last year with 2 big manufacturers of insulating panels and boards, one in Germany and one in the Netherlands, for recycling of the production waste, so in-house recycling again. So that are the pictures of the plant in Germany, some parts of the plant, and that is the installation for rigid foam recycling in the Netherlands. And of course, it is very exciting to mention that our next unit is being under installation right now, and it is happening in Mexico. And we are very proud of it. This is also a rigid foam recycling unit. You can see the picture. It is very fresh one from yesterday. You can see that, the installation works are in progress, and this plant will be in operation already this year. The next one will be also in Mexico, and it will be again for Ecano industry, for slab stock, for post-industrial waste. It will be in operation next year. So, and I'm nearing the conclusions already. I think it's important to recognize that while our solution, of course, may not fully resolve this global issue of polyurethane waste, but in my opinion, it represents a significant step forward, because this implementation, and I underline successful implementation of the projects in Europe and now also in Mexico, it is really highlighting the potential of this technology and the scalability of this solution. So I believe that our technology not only promotes circularity, but it is also underscores its profitability, because we have this economic viability and this practice of our customers, which is showing every day that this technology is viable from both sides, from technical and from economical standpoint. And I'm very proud that we can contribute to this whole story of polyurethane sustainability and reshape it also a little bit. So I thank you very much for your attention. And of course, you're welcome to ask any questions. I have also my colleague with me, head of our R&D department. So if there will be some technical or chemical questions, my colleague will join me to assist.
Thank you. Okay, muchas gracias.
Gracias.
Gracias, Nela. Bueno, muchas gracias por su atención y espero que sí tenemos preguntas. Seguramente hay muchos. Podemos iniciar una sesión con un poquito de atención a sus necesidades o sus preguntas básicas que tienen. Yo les invito entonces para iniciamos esta ronda. Pues,
¿Viste el primero? René Álvarez. ¿Ya pueden entrar?
No.
Tenemos una pregunta de René. René, adelante, por favor.
Gracias. So I will try to do my question in English. So what is the minimum quantity of foam that you require for in order to produce a good batch of the new polyol, the new recycled polyol?
Okay, thank you for the question. So our standard reactor, of course, it depends on flexible or rigid foams, because we have found out that it really has impact on this batch size. But if I'm talking in general, it's a 5-ton batch, which means that
Okay.
5-ton product of recovered polyol we can generate for 12 or 13 hours. And from this amount, we need between 40 and 50% of polyurethane waste. And you can run this unit 2 times per day. So that means 2 batches per day.
Okay, thank you so much.
You're welcome.
Okay, si por favor, a la hora de presentarles bien su nombre y su compañía, tenemos a Ana Gabriela López Castellano. Por favor, adelante.
Hola, buenos días. Una pregunta. Si nosotros no tenemos el espacio suficiente para colocar una planta como las que nos mostraron, ¿ustedes cuentan con alguna planta donde nosotros podamos enviar nuestro foam para todo este proceso de reciclaje?
Sí, precisamente ese es un tema para el futuro. Sí existe el long recycling, como lo llamamos. Es decir, hay centros de acopio a donde mandan sus desechos cuando son menor para un in-house recycling. Sí existe la posibilidad, pero hay que decir, en México es nuevo. Nosotros empezamos hace muchos años, un ejemplo de fue muy temprano, hace 17 años, aquí en León mismo, pero hoy día sí depende de la organización, qué desechos son, de qué origen viene, qué colita, poliéster es, qué espuma, qué poliol es que institucional. Es un poquito en camino nuevo, pero sí existe esta posibilidad. Estamos presentando, si más tarde lo podemos mandar más información, o si hemos hecho este estudio antes, sí.
Sí, déjame agregar ahí algo, John. El objetivo principal es cerrar el círculo. Entonces, si ustedes generan o tienen manera de recolectar este desecho, después reciclarlo, ya sea, si ustedes no tienen un lugar donde colocar el reactor, con algún reactor que esté por la zona, y esa espuma que produzca el reactor, ustedes la pueden volver a utilizar. Eso facilita mucho más el proceso entero, ¿no? Ahorita ese es el camino que estamos buscando. Uno es la entrada de desechos que puedan poderse reciclar, y la otra es la salida de ya esta espuma, este poliol reciclado, que en el orden de entre 15 y 20%, cuando lo mezclas con poliol virgen, se puede volver a utilizar en tu proceso sin ningún problema. Entonces, ese es el objetivo que buscamos, cerrar el círculo de la circularidad, valga la redundancia.
Ok, gracias. Si me pudieran enviar más información, se los agradecería mucho.
Mucho gusto. Bien, tenemos Martín Cortés, la compañía que representas, y tu pregunta, por favor.
Hi, Mila. Thanks for your explanation. It was really good to understand how other companies are working on this. I'm representing a Flexi Footwear here in Mexico, and we have a lot of production on polyurethane based shoes. My question here is we are changing our raw material to polyether based production. So I want to understand what's the difference between recycling polyether and recycling polyester based products. Can you help me with that?
Okay. Hello, Martin. Thank you very much for your positive feedback and also for your question. As I mentioned, I have a head of our R&D, Mr. Dr. Valentin Stoichev, and he was really doing a lot for shoe soles, recycling, investigating this subject. So I will address this question to him to explain what is the difference between polyester and polyester foam recycling.
Hello, good morning, everybody. My name is Valentin. I will try to answer your question. The difference is just that we use two different recipes for recycling of polyether or polyester. We don't recommend to mix polyether and polyester waste because after that you don't have the possibility to use it clear in polyether or polyester applications, and you will have a stronger separation. Polyether and polyester polyols by itself don't like each other, and you have a separation in your storage tank. So the recipes are different. For polyester, we go in the way aliphatic polyester recycling system, and polyether we start and go in the way to polyether recycling polyol, so that you can use it back for polyether.
But the process, thanks for your explanation, but the process is the same. We just need to make a different recipe?
The process and the installation is the same.
Okay, good.
So we need to change some of the reagents just to adapt the recipe from polyester to polyester and polyether to polyether. Of course, there are differences like the raw materials in the viscosity between polyether and polyester, but you know that I don't need to explain you.
Okay, good. I'm sorry. Can I have another chance for another question?
Of course.
Yes, go ahead.
Okay, so those places that you have shown in France and Netherlands, are those placed for mattresses? Because I saw a big infrastructure there.
Yes, they are in France and in the Netherlands, they are for recycling polyurethane flexible foam, which is extracted from end-of-life mattresses, from old mattresses. So the infrastructure actually is similar for in-house waste recycling, because they do not dismantle. Okay, beside Retour Matras, because they were already in the business, they are dismantling the mattresses. But for example, the plant in France, they receive already these bales of the foam from French extended producer responsibility organization. So they receive it as a raw material. They don't dismantle the mattresses on their own. They just receive pure polyurethane already.
Yeah, my question was related to the size of the place, because I was imagining here for Flexi a more small place to recycle our waste, because the shoe companies produce less amount of polyurethane
it could be small
versus mattresses, right?
It could be smaller, depends, of course, on your amount of waste. In general, the plants which you saw in the Netherlands and in France, they are like 30 by 20 meters. This footprint.
Yes.
It's maybe not that huge as it looks.
Martin, let me just to clear after the post-production or post-end of life. So we are talking post-production waste from Flexi, which is around, it must be around 200 tons a year. Then it makes sense to make an in-house recycling at the Flexi facilities or around that. And end-of-life shoes is a different story. So that is a different way to handle the recycling. And shoes, I do not think it is yet very well. We cannot do it that way because all the shoes, as you mentioned, when you sample them or put them on waste, you need a lot of shoes. And to separate the shoes from the upper, that's almost, it can be done, of course, but who is separating the shoes or gathering the shoes? But,
yes, John, thanks. What I'm thinking is to put something similar, but just for our production waste.
Yes, exactly. That is
because
something good for you.
We produce a lot of waste in our processes, so we should start with this as soon as possible.
Yes, and your people are in Germany in September, and HNS is also on the Desma House Fair, so we can have a further discussion there. Your people are there, and I think, I don't know if you go, but about 4 or 5 people from Flexi make already registration. So we might actually talk there with HNS also.
Yeah, I believe Ramiro, that is also here in this webinar, he's going to attend that. So I'll make sure that he has all the information needed to bring what we need. All right.
Yes. Okay. Thank you.
Thanks.
Gracias, Martín. No tenemos otra pregunta. ¿Alguien más que tenga alguna duda, por favor?
Yo tengo una pregunta para Martín. ¿Quién es su actual proveedor de sistema?
¿Con sistema te refieres a materia prima?
Sí.
Sí.
Pues mira, estamos migrando casi todo para DAO.
Ok. Muy bien.
Entonces,
Gracias, Martín.
la realidad, Ernesto, es que nosotros tenemos quien nos ayude a reciclar nuestro desperdicio base poliéster. Ya lo hicimos pruebas, funcionaron y funciona bien. Pero como estamos migrando todo a poliéster, y nuestro objetivo en cierto tiempo es tener todo poliéster, pues ahí es donde quiero yo entrarle.
Muy bien. Gracias.
¿Alguna otra pregunta?
¿Alguna otra pregunta?
Yes, Arturo Caballero, I have a question for Mila. Mila, which is the difference of the process for recycle the polio with a foam with a white color and black color? Is a similar process or is it different?
Yeah, it's a similar process. The point is that the recycled polyol, which will be resulting from the process, it will have different grades. If you're recycling black foam, the polyol will be also black. If it is white foam, then it is depends on if it is flexible or rigid. It's like from caramel to dark brown. It's only the issue of the color, but nothing else.
Okay, is possible to share your presentation for us, please?
Yes, I will share your presentations. Maybe some pictures I have to extract because of the confidentiality, pictures of the equipment, I mean. But what is allowed to keep it, of course, I will share. No problem.
Perfect. Thank you so much. Thank you.
You're welcome.
¿Alguien más?
Sí, adelante, José Luis.
Adelante, José Luis.
Gracias, Ernesto. Pues a todos, para mí es la oportunidad de presentarnos. Somos en Repare. Repare es parte de Invera, que es una empresa de refrigeración comercial ubicada en San Juan del Río. Y nosotros somos los que operaremos o comenzaremos a operar este primer reactor dentro de este año. Y pues por supuesto que cualquier oportunidad para compartir aprendizajes nos encantaría. así como también la oportunidad de poder presentar estos polioles que estaremos recuperando que estaremos fabricando durante este año. Y si es del interés de alguno de ustedes, pues por supuesto que estamos abiertos a poder entablar alguna relación comercial. Muchas gracias a todos y gracias a Michelet por la organización del evento.
Gracias.
Gracias, José Luis. ¿Alguien más? No, muy bien.
Bueno, pues vamos a terminar entonces este webinar. Fue la primera vez que lo hacemos. Espero que podamos servir en el futuro un poquito más y cualquier información requerida. Ya están los datos de cada uno de nosotros disponibles, tanto de HS, tanto de nosotros en México. Se sienten libres a buscar cualquier información necesaria para podemos suministrarla a la MED. Aquí están nuestras direcciones, ahí están todo lo necesario, los emails, celulares. Es bienvenido a hacer preguntas o requieren información. Vamos a enviar la presentación como es, menos algunos slides que dice Mila que vamos a quitar por confidencialidad, pero sí cualquier información requerida lo enviamos. Les agradezco mucho la participación y su interés y espero que nos vemos en el futuro pronto. Muchas gracias y hasta luego.
Muchas gracias. Hasta luego.
Thank you, Mila. Bye.
Adiós.
Gracias.
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 Bye bye.
Adiós.